Ma'am, you are neither audible and
Hello.
Yes, ma'am.
Okay, now
Yes,
we are
ma'am.
here. So I was explaining in the last class what are eigenvalues I have explained, eigenvectors I have explained how to find out, and there were some properties that I was discussing. Most of the properties I have covered, and the other one that I was about to explain was if lambda is the eigenvalue of the non-singular matrix A, then this is the eigenvalue. Like, okay, you can name the property number. I don't remember what was the number. The eigenvalues of either 0 or 1. So idempotent matrix, I think you know. Have you heard this name?
Yes, ma'am.
If A square is equal to A, then it is called the idempotent matrix. So same way you can prove that we were doing in other class also Ax is equal to lambda x. Again you take A common both sides. From that you equate the equation, you will get the value. So proof is actually not required. You can remember. And if lambda is an eigenvalue of matrix adjoint of A. So these are the cases. Like if I give you one simple example, like if you have a 2 by 2 matrix, okay, 2 by 2 matrix is there. Then because to find the eigenvalue, it has to be a square matrix because determinant is involved over here. Okay, so wherever determinant is there, you have to have a same order matrix, square matrix. So if you have eigenvalues are 4 and 9 of this square matrix, since it is of order 2, so there will be actually 2 roots because you will get a polynomial of degree 2. So you will obviously have two values. So these are the eigenvalues. And what will be the eigenvalues of the matrix AQ? 5, 0, 0, 0. What will be the eigenvalues of AQ? X, Y, Z. If this is the eigenvalue of A, eigen, huh?
64.
4 cube and 9 cube.
Yes, 4 cube and 9 cube. So likewise, you can get the property also. If like 4 is the eigenvalue of the matrix A, then what will be the eigenvalue of A inverse? So all those properties you can use. Now let us come to another thing, Cayley-Hamilton's theorem. So equation
2x minus 4y plus 8 and 10 is equal to 0 minus 5y plus 5z is equal to 0. For the third equation, that is
Cayley-Hamilton's theorem. So to get the eigenvalues, what we were doing, we were taking the characteristic equation a minus lambda I is equal to 0. And solving this, we got eigenvalues. Okay, because we were getting a polynomial, and then we were getting the eigenvalues. Now, what this Cayley-Hamilton's theorem says that if you have a matrix, that matrix will satisfy its own character. So, whenever you're solving this equation will be called as characteristic equation. Do you remember? This equation was given the name as characteristic equation, which is actually a polynomial of degree, which is same as order of the matrix. And solving that, we were getting the eigenvalues. Now, Cayley-Hamilton's theorem says that the matrix will satisfy its own characteristic equation. Like if you are having the characteristic equation, when you are taking a determinant of a minus lambda I is equal to 0, you are getting, suppose, any characteristic equation like this: a to the power n plus some time a to the power, like some constant any values, which will be based on lambda a to the power n minus 1, and so on. Okay, so this matrix must satisfy this characteristic equation. That means left hand side term should be equal to right hand side term. Got it? What I mean to say?
Ma'am, please explain once again.
Okay, let us take one example. You are having a matrix 2 and 1, 3 and 2. Now, what are the characteristics? What is the characteristic equation of this? Determinant of this is a. So a minus lambda I is equal to 0 will be the characteristic equation. So when you are doing it, so you will get 2 minus lambda, 1, 3, 2 minus lambda. So when you solve it, you will get 2 minus lambda whole square minus 3 is equal to 0. Isn't it? The characteristic equation you are getting this. Now, this Cayley-Hamilton's theorem says that the matrix A will satisfy this characteristic equation. Satisfying means what? It has to be replaced by that value. So you will get 2 minus A whole square minus 3 will be equal to 0. That means this matrix A, when we put that in the characteristic equation, the left hand side term and the right hand side term will be equal. Actually, one main application of the Cayley-Hamilton's theorem is that if you know the characteristic equation, you can find any order of the matrix, any degree term. Like if I tell you to find a cube, then from the characteristic equation only you can do some operation and you can find. If I tell you a to the power 100, then using the Cayley-Hamilton's theorem you can find. If I tell you a to the power a inverse, then using this you can find by doing some operation. Okay, so this is one major use of this theorem. Okay, now this is understood. So Cayley-Hamilton's theorem is actually that it will the matrix A will satisfy its own characteristic equation. So this is the characteristic equation. Satisfying means what? You have to replace that unknown value with the given variable. Like when we have the equation x square minus 2x is equal to 1, we say that x is equal to 0, we will satisfy. That means left hand side, if you put the value of x equal to 0, left hand side term should be equal to right hand side term. So that actually means satisfying. Got it? Now let us do one example. Verify Cayley-Hamilton's theorem. I'm writing in short, CH theorem. For this matrix, matrix is given to you.
Just tell me. Yes, or tell me the first step.
So to verify the Cayley-Hamilton's theorem, we construct the characteristic equation.
What is A minus 3A now?
Determinant of this is equal to 0. Now you construct the equation.
Yes. Now what we have to do now? We have to find the
So if you take the determinant, then you will get some polynomial.
So we have to find that.
So what polynomial you are getting?
Yes. So I want this to know what it looks like in form and tell me the final matrix.
And we can first reduce this matrix determinant.
You can do the row operation or directly also if you want you can do. This you can take multiply then minus of this. Then you hide this middle term, this into this minus this into this plus 1. This into this minus this into this. That way also you can do.
2 minus lambda whole cube minus lambda is equals to 0.
2 minus lambda whole cube
Plus lambda is equals to 0.
plus lambda is equal to 0. So if you break it, what you will get? Are you sure you are getting this value? I have a doubt. Because there are other terms also. So how do you find it? You take 2 minus lambda into this 2 minus lambda whole square minus this becomes plus and this becomes minus. Now what will be the sign of this? If you take minus, then this
Plus
into
one.
this.
Plus
If you take plus, then you have to take this into this. So what you are taking? Plus this term. Or you are taking this term?
ma'am plus 1 into minus 1 into 2 minus lambda and plus 1 then.
Okay. Minus 1 into 2 minus lambda. Minus plus 1. Okay, plus 1. This, so you have 1 minus 2 minus lambda. Now you simplify. So you will get is equal to 0. You will get something. Lambda cube minus 6 lambda square plus 9 lambda minus 4 equal to 0. You check out.
Yes, ma'am, correct.
Okay.
Yes, ma'am.
Now what Cayley-Hamilton's theorem is saying? It will satisfy, the matrix will satisfy its own characteristic equation. So you have to replace the lambda with A. By Cayley-Hamilton's theorem, A cube minus 6A square plus 9A minus 4 is equal to 0.
Anyone other?
Now verify means what? You have to prove that left hand side is equal to right hand side. See, one thing you can see from here, if I tell you to find A cube, what is the value of A cube? So instead of multiplying A into A, you get some result. Again you multiply A to get A cube. So this will be time taking. So what you can do, you can take A cube is equal to this term. So that will be the answer. That also you can do. If I tell you to find A inverse, what you can do? You can take A inverse from both sides. So this becomes A square minus 6A, no, this is A cube minus 6A square plus 9A minus 4. So A inverse into this will obviously be 0. Now if you do the operation, we know A into A inverse is equal to I. So this power will decrease. So this will become A square minus 6A plus A into A inverse is equal to I. So that will become 9 into identity matrix minus 4A inverse.
No. Right.
Isn't it? You got it? So from this, if you this is equal to 0, from here you can get A inverse. A inverse will be equal to 1 by 4 times A square minus 6A plus 9I. So this is actually these are the uses. One good use. You can find a cube also. You can find a square, any value. If I tell you to find a to the power 100, then also you can do it if you get some simple expression. Okay, right now you verify and you check.
For the first equation, 5x.
Now to verify it, what you have to do, you have to multiply this 3 times. Okay. And this also you have to take 2 times and this, and then you add all the matrices.
X is equal to minus x. So the vector x is equal to x minus z minus z to z. That is minus 1 minus 1 by 2 1. So the remaining vector is okay. You tell me the eigenvector. Sarah, have you done this now?
Finished?
Sarah, close. Okay, just check it. Now tell me the next one. Who is going to tell me eigenvector for lambda? Ishika Shwarya is there. Ishika. Ishika, tell me the eigenvector. Find eigenvector for lambda 15. और जल्दी करना टाइम ही लगा देना हेलो 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 क्या हुआ बेटा मेरा है ना वो एक सेमिनार चल रहा है
Finished?
प्रेजेंटेशन चल रहा है मेरा तुम बैठो ना क्या कह रही है नेटवर्क चल बात कर लो
Yes, ma'am.
Okay. So all of you have done?
क्या क्या बी
Are you getting the left hand side equal to right hand side?
Yes, ma'am.
Okay, now let us come to one nice example. If we are having a matrix, matrix 2 by 2 matrix we are given. Okay. With eigenvalues 1 and minus 2. And eigenvectors. Okay. So this is eigenvalue. Okay. And eigenvector suppose x1 and x2. So this for x1 we have the eigenvector this, for x2 we are having the eigenvector. Then what will be the eigen values and eigenvector of this equation? So what will be the eigenvalues and eigenvector of this? You can use the Cayley-Hamilton's theorem itself. Can you use it?
Yes, ma'am.
Because when we were doing the Cayley-Hamilton's theorem, we were replacing the characteristic equation because it was said that every matrix satisfies its own characteristic equation. So from the characteristic equation, we were getting the value of lambda 1 and lambda 2. Isn't it? If you move backward, so what you can get these terms in terms of lambda. So you can write this in terms of lambda square minus 3 lambda plus 4i. Isn't it?
Yes, ma'am.
Now, this lambda was actually the unknown eigenvalues. But over here you have a known eigenvalue. Just you replace this with when lambda is equal to 1. When lambda is equal to 1, then you will get one eigenvalue. When lambda is equal to minus 2, you will get another eigenvalue. So what are the eigenvalues?
2 and 14.
Yes, 2 and 14. Now, will this eigenvector be the same as x1 and x2, or it will have a different eigenvector?
Same.
Why? Yes, it is right. Same eigenvector. Why? Anybody?
Because
Yes, each like that. What is the first step?
Okay, you can think over this. I will ask you at the end of the class. Okay, now let us take one example. A small one. Okay, you are given the matrix 1, 2, 2 minus 1. This is the matrix. Find a to the power this. So if you multiply this 8 times, it will be really very difficult. So what is the shortcut method? What is the shortcut method?
Elemental theorem.
Yes, yes, you apply that theorem. So for that, first find the characteristic equation, replace lambda with the matrix A, and then do some operation. You have to check out what you have to do.
625.
Yes. So fast you did. Post your solution. Let me see. So this is one of the major application of the theorem. It is easy to do the computation.
You people are going to after 2 days, but you are planning your office.
Okay, again I give you one example. You are having the matrix.
I will check whether you are doing it in your office.
You are having this matrix. Then what will be the value of this term? So what will be the value of this equation?
We are doing so many times. We not solving like this. And Monday we have to do them. We are not able to find the
AQ minus 5, 7 plus 7. So what is the value of this? So if you keep on multiplying and doing, your entire period will go out. So what you do, you apply the Cayley-Hamilton's theorem, and then you try to simplify. Using that part, you try to simplify this term. Like if you have this equation, characteristic equation. So when you apply the characteristic equation, you will get some equation. Okay. You tell me what equation you are getting, then I will tell you. Then what you do, you try to simplify this equation in the form of the equation that you are getting over here, because whatever equation you get, that will be equal to 0.
Good morning, sir.
So if you use this part in this calculation, then some part will become 0. Can you follow what I am saying? क्या समझ में आ रहा है? और जो कैरेक्टरिस्टिक इक्वेशन हम निकालेंगे, उसमें से एक पॉलिनोमियल निकलेगा. पॉलिनोमियल निकलने से अगर हम उसको satisfies this characteristic equation, so this is of order 3. So third degree polynomial निकलेगा in terms of AQ. अब इसको क्या करना है? AQ plus some term into AQ plus some term into A square, some term into some constant will be equal to 0. कुछ आएगा ऐसा? क्योंकि ये third degree है. अब ये जो equation is equal to 0, what you do, you try to express this equation in some form. There will be some term into this expression. plus some term into this expression, so that or remaining अगर नहीं बनेगा that will be the remaining expression. So यहाँ पे 0 हो गया, यानी ये calculation कम होते जाएगा. This will become 0. So the remaining part you can easily calculate. So that will be the answer. Got it?
Yes, ma'am.
हाँ, अब ये बताओ ये वाला कितना आ रहा है?
lambda cube
हाँ, lambda cube
minus 5 lambda square plus 8
minus
lambda
5 lambda square plus 7 or 8 lambda. Check out.
plus 8 lambda.
All of
Minus 3 equals to
7 lambda.
7 lambda.
Yes,
Check
7
out
lambda.
there.
7 lambda
7 lambda minus 3 is
Yes, right.
minus
7. Huh. So now whatever lambda will be replaced by the theorem. So you are having a cube. If you have a descriptive question, so don't just replace a lambda by a cube. You write the theorem why you are replacing. Okay. You write it in the bracket since by Cary-Hamilton's theorem. Okay. Directly if you replace, that has no meaning.
Tell me the final matrix.
7 minus 3 is equal to, so 3i you can write it as 0 is the identity matrix. So this you are getting. Now you try to express this equation with some term which will contain this also. Try to express. So if you take it as over here, this is 3. That means you can take 5 over here.
Yes, sir. Yes, sir.
So what you can do?
Yes, sir. Your voice is clear, sir.
So this you can write it as a to the power 5. If you want, you can write it as a cube minus 5a square plus 7a minus 3i. So this is matching a cube. Minus 5a to the power 7. This is also matching. Now this is 7a to the power 6. This is also matching. Now this is not matching. Is this matching? Yes, this is also matching. So this part is okay. यहाँ से यहाँ तक मैच करिए. अगर मैच नहीं करता तो वो यहाँ से माइनस कर लेते, ठीक है? यहाँ पे मैच करिए तो कोई नहीं. Again you can write plus. यहाँ पे फिर है a you can write a cube minus 5a square plus 7a.
अपना माइक सही करके ना इसको पास लो.
Now this is a to the power 4. This is also matching. Minus 5. This is also matching. And this is 8a square. So you can minus. This is 7a square. So minus a square. ठीक है, यहाँ पे 7 आ गया. Minus 3i. So this is actually minus 2i. So what you can do? Minus a. देख सकते हो?
Plus a square.
Okay, yes, yes, plus a. ठीक है. Plus a. अच्छा यहाँ पे भी शायद ये ठीक है. यहाँ पे
plus a square है.
हाँ प्लस हाँ ठीक है प्लस ए स्क्वायर ये आ गया प्लस आई तो ऑलरेडी था. अब क्या हुआ? ये तो 0 हो गया, ये 0 हो गया, बचा क्या? दिस. नाउ दिस इज अ सिंपल. ये कैलकुलेशन करने से अच्छा है कि ये कैलकुलेशन हो छोटा हो गया. अब ये तो आगे यू कैन नॉट रिड्यूस फर्दर. यस प्लस होगा ये कि यहाँ पे 7 था, यहाँ पे 1 चाहिए था 8.
Those who are not responding, I am marking their absence. Eva. Sorry, yes. What your minus 40? Is it so? Okay. So this is so rank is 2. So the number of unknowns is 3. So linear independent eigenvectors is 3 minus 2, 1. So from this let us write our system of equation minus 7x minus 6y plus 2z is equal to 0. 20y plus 40z is equal to 0. This implies that minus y is equal to minus z. Okay. Minus 2z. Substituting the first equation. Minus minus will get cancelled, so that is it. Okay. No issue. It is like this, you can cancel. So minus 7x This is minus 12z plus 2z is equal to 0. So 7x is equal to 14z with 5x is equal to 2z. So the vector is x is equal to x y z 2z minus 2z z 2 minus 2 1. Independent eigenvector is 2 minus 2 1. Okay. So this is your eigenvector corresponding to lambda is equal to 50. Model so see the model for example, the matrix is 3 cross 3. Okay. And my eigenvalues are lambda is equal to 2. All the eigenvalues.
Yes.
I'm 30.
What others are getting?
Eigenvalues are 2, 1.
No, you will not get a number because it will be a matrix, no?
The number of eigenvectors will be can be
You will get a matrix, not a single number.
1 corresponding to lambda is equal to 2. It can be 2, it can be 3. ऐसा नहीं होगा कि एक eigenvalue तो एक ही eigenvalue है. It can be 1 eigenvector, it can be 2 eigenvectors, it can be 3 eigenvectors, it can be 2 eigenvector matrix. And this problem we have done in the class. Okay. So let us see next problem.
From after the final, after reducing it, what's the equation coming out?
This is the equation, what I have written. See, when you simplify this big expression, finally this is the equation, the circle one. Because this is becoming 0 by using this.
Okay, I got minus 4a square and rest is same. I think I made a mistake.
So this will happen, a square plus a, means that original equation is reducing to this equation.
I got that. Okay, I think I've made a mistake somewhere in that.
So this is the beauty of the theorem. Now what you have to do, you take square, you take a, you do the operation. So finally what you will get a matrix itself, because this is a matrix, this is a matrix. You will not get a real number, a single number, singleton number you will not get.
Hello, ma'am.
And yes,
Ma'am, we have to reduce the given matrix, then we do this expression.
see one thing. You are saying you have to reduce the
Expression given A expression.
okay, I ask you the same thing. Suppose you are not reducing it. Your main task is to find this equation. This is a very big equation which contains a to the power 8 minus 5 a to the 7 plus 7 a to the power 6. If you don't reduce it, so how easy will it be to calculate this expression? Will it be easy for you to calculate this expression? Huh?
No.
Yes, it will be time consuming because you have to multiply into a. Again, you will get a square. Again, you multiply with a. You will get a cube. Again, you keep on multiplying. How many times you have to multiply?
8 times.
7 times. Because when you are taking a square, you are multiplying 1 time. So if you find a to the power 8, you have to multiply 7 times. These also already you are getting. Again, after multiplying, you have to do a big addition subtraction.
This will happen.
Can you follow what I'm saying? So if you use this Cayley-Hamilton's theorem, your calculation will reduce. Now see, is this easy to calculate or it is easy to calculate this? Which one is easy for you? Obviously this one, because there are only 3 terms and that is also simple term a square. So it is easy to calculate this rather than to calculate this. That is why Cayley-Hamilton's theorem has a very beautiful use of reducing the expression and finding the value of the whatever is given to you into a simple form. क्या समझ में आया? ये एक बहुत अच्छा एप्लीकेशन है. मतलब अगर कोई बड़ा सा कोई इक्वेशन रहेगा उसको अगर अपन सॉल्व करने में बहुत टाइम कंज्यूमिंग होगा या हो सकता है भूल भी हो जाए. इतना बड़ा एक्सप्रेशन को सॉल्व करना है तो पेज भी लगते जाएगा. तो ये हैमिल्टन थ्योरम यूज करने से क्या हो गया? ये एकदम छोटा बन गया क्योंकि यहाँ पे तो ऑलरेडी सम पार्ट 0 हो गया. ये वाला प्रॉपर्टी से हमारा एक इक्वेशन निकल गया. ये इक्वेशन को यहाँ पे डाल दो, छोटा हो गया. छोटा होने से अब ये कैलकुलेशन छोटा हो गया. यस
855 at a first row.
Yes,
030
030
and 558.
Yes, right. Yes, it is right. सबका आया ना ये. Post करो, post करो.
Yes, ma'am.
Ma'am, I did it at the rough, ma'am. So just
Sometimes students make a big mistake. Like if we give a big expression, they use the entire booklet in solving this problem, and then they will say it was a lengthy question. We don't have page. तो students ये बोलते हैं, तो थोड़ा cleverly use करना technique को. Where it has been posted.
ma'am, I was saying that I did it at rough, so I did.
Okay. And the previous problem also, which I gave to find a to the power 8, that also somebody posted, so that others who have not done, they can just have a look.
Chat box में yes करने से कुछ भी होगा. If your mic is not working, you have to.
Okay, now I ask you one question. What is the application of Cayley-Hamilton's theorem? What is the application? Why you are studying it?
To
To compute
reduce
higher powers of
length.
matrices and
Yes.
larger expressions.
Yes, that can be one answer.
To convert a larger expression into the smaller expression by using them.
Yes. And another answer that you can give based on the problem that I have given you now.
Can be used to calculate inverse of a matrix.
Yes, you can use to calculate inverse of the matrix. Again, next.
Were you present in the class when I have done the Cayley-Hamilton theorem?
We cannot calculate, we can easily calculate the inverse of the matrix. नहीं तो फिर क्या करना होगा inverse निकालने के लिए adjoint of a by determinant of a, उसमें adjoint निकालने में भी time लग जाएगा, इससे आसानी से निकल जाएगा. And you can find any power of the matrix easily. नहीं तो if you don't apply this theorem, you have to keep on multiplying the matrix several times to get the power of the matrix. Now over here you can easily do it. Okay. Now let us come to another example.
Again, I have to multiply with A inverse. It becomes A minus 85 plus 45.
We have the matrix.
A inverse is coming out 1 by 45, 80i minus 8.
This is K, okay?
इसको verify कर सकते हो whether this is coming out.
This is also K. A is the matrix and you are having the vector.
Yes.
Okay, fine.
Nothing to remember.
Values of K
How to find A power 4?
for which Ax is equal to 0 has infinite solution.
How to find A power 4 now?
Has infinite.
In terms of A.
Infinite solution कब होगा? ये किस टाइप का इक्वेशन है?
In terms of
इक्वेशन टाइप देखना.
Homogeneous.
तो होमोजेनियस में क्या प्रॉपर्टी है?
Expression of A4 in terms of A.
इसमें सोल्यूशन किस टाइप का होता है?
If rank of A is less than 2, then it will be
Yes.
solution.
Yes, yes.
What I should multiply with so that I can get A4 in terms of A's. Simple किससे multiply करेंगे? A से multiply करो तो क्या है? A4 minus A3 A2. What is my A power 4? Tell me. ठीक है आशीष अगर समझ में नहीं आता है तो मैं किसी बात कर रहा हूं तो करो मेरे सॉल्व कैसे आएगा why you are not going to that one? I have already uploaded.
I hope all of you all are sitting with your copy. I think. Is anybody over here who is not sitting with a copy and just kept the system on and roaming around?
We have it on one day.
सब लिख रहे हो ना कॉपी में?
Yes, ma'am.
Yes, ma'am.
What that person say, ma'am?
Okay.
क्योंकि ऑनेस्टली पढ़ाई करने से अच्छा है ना।
If you have any issue, please ask me.
A is not equal to 2 rather than everything is equal.
हाँ क्या आ रहा है?
K not equal to 2.
Are you sure? एक बार चेक करना।
Next is Anush.
ठीक से चेक करो।
2 0
K equal to 0 और क्या आ रहा है? अगर K 0 हो जाएगा तो क्या हो जाएगा?
A equal to -2.
नहीं ठीक से K equal to again -2. No, you check out.
2 मैम।
Yes,
K
K is
equals
equal
to
to
2 and K equals to -0.
0।
अच्छा, तो इनफाइनाइट सॉल्यूशन कब होगा?
बोथ केस में।
ठीक है तो
सब लोग निकालोगे और जो भी किया है मुझे अभी सब लोग व्हाट्सएप में फोटो खींच के भेजोगे।
okay, if you take a K value 0, you will get a null matrix. Will that be possible? एक जीरो मैट्रिक्स आ जाएगा, तो जीरो मैट्रिक्स होने से यानी लेफ्ट हैंड साइड इज आल्सो जीरो, ये दिस इज हैज नो मीनिंग।
यस मैम,
है ना?
yes
Because otherwise you will not get this. It has to, that means your matrix singular ही हो गया है। singular होने से तुम्हारा determinant भी नहीं होगा कुछ, तो ये वाला नहीं consider होगा। So we cannot consider this case. So only the case is K is equal to 2. Got it?
yes
Yes ma'am।
Yes ma'am।
Okay, I have finished this module also. बहुत सारे problems करा दिए हैं। Properties को याद रखना। Properties will be helpful for doing the MCQ questions, whether you get it in BIT or outside BIT for gate weight and etc. And let us.
Ma'am, please tell the reason why that vectors were same at that time.
Okay, anybody can answer. You just think over it. बहुत ज़्यादा difficult नहीं है। Answer मिल जाएगा। ठीक है। Next class में कभी discuss करेंगे। अपना थोड़ा सोचो।
Ma'am, maybe because the matrix was 2 cross 2, so that's why, or another reason.
नहीं सोचना, आंसर मिल जाएगा। अच्छा ये दिखाना था हमको, फाइल्स, सिलेबस। So this I have covered everything. Rank of the matrix, transformation, echelon form. अच्छा echelon form बताओ तो क्या होता है? What is the echelon form?
आइडेंटिटी मैट्रिक्स जब आ जाए एक साइड में,
हाँ
वन साइड में आइडेंटिटी मैट्रिक्स।
हाँ, और बाकी का क्या होगा?
0।
यस,
बाकी 0।
हाँ बाकी 0 होगा। लीनियरली इंडिपेंडेंट डिपेंडेंट भी बता दिए हैं। इसका चेक करने का तरीका कितना तरीका है सब बता दिए हैं। किसी का ड्रॉबैक भी बता दिए हैं। अगर हम लीनियरली इंडिपेंडेंट और डिपेंडेंट चेक करते हैं तो अगर डिटर्मिनेंट लेके इक्वल टू 0 करते हैं तो वहां से भी पता चल जाएगा, लेकिन वहां से क्या होगा, अगर डिपेंडेंट होगा तो रिलेशन निकालना मुश्किल होगा। ठीक है, तो उसमें तुम स्केलर्स लेके करना अगर रिलेशन निकालना होगा, क्योंकि वहां पे तो कोई इक्वेशन नहीं बनेगा ना। तो वो हो गया। कंसिस्टेंसी भी बता दिए हैं, होमोजेनियस नॉन होमोजेनियस केसेस का, आइगन वैल्यूज आइगन वेक्टर भी हो गया है, कैलिया-हैमिल्टन थ्योरम भी हो गया है। ओके, वी विल मीट इन द नेक्स्ट क्लास। Okay, bye now.
Thank you ma'am।
Thank you.
Thank you.
Thank you.
हेलो भाई,
मेरा आवाज सुनाई दे रहा है क्या?
हाँ
दे रहा है। बाकी
हाँ।
सेक्शन तो 31 को क्विज है।
अगर बोल रहे हो तो नहीं सुनाई दे रहा।
मैम से क्विज का पूछ लो भाई।
भाई खत्म।
भाई कैसे खत्म?
अबे कुछ समझ में
अभी तो जस्ट शुरू हुआ था, कुछ तो समझ में आया नहीं।
मैट्रिक्स कुछ ज्यादा ही जल्दी खत्म हो गया।
ये ईसी का शायद 31 को है किसी ब्रांच में।
और मैक का भी है,
नहीं,
मैकेनिकल
सबका
का भी
एक साथ
31 को
होगा।
है। हाँ और
सबका
मैकेनिकल
एक साथ ही होगा ना?
हाँ
नहीं
लोग को
ऐसा
लास्ट
नहीं
में
है।
सरप्राइज
केम
देगी,
केम वालों
किसको
में
बोलेगी
मैथ
आज एग्जाम है।
31 को है।
इसी का हम लोग का सेकंड को है।
नहीं
हम लोग का तो सेकंड को है।
अबे वो
मैथ का
ईसी और
कहाँ देख
मैकेनिकल
लिया
में
भाई
बोल रहा है
31
मैथ
को?
के
मैथ का
31 को
किसमें
है।
31 को है? मैथ का
केमिकल
किसमें
में
31 को?
केमिकल में
मैथ्स का
किसमें?
इसी में, इसी में
सब में
ईसी में और
और
मैकेनिकल में।
मैकेनिकल में।
भाई सबका एक ही साथ होगा ना?
हाँ
भाई
हम लोग फॉर्म थोड़ी
केमिकल वालों की लगी है, अभी पूछा है एक से।
चलो कैलकुलस
मैम का नंबर है क्या किसी के पास?
उस हिसाब से तो यहाँ तो केमिस्ट्री वाले से पूछो कि सर पोस्टपोन तो नहीं है क्विज, कहीं हमारी मैथ की भी 31 को ही हो।
हाँ क्योंकि शाम में मैथ्स का और केमिस्ट्री वाला तो सुबह में ही था ना सर बोले थे।
हाँ टाइम अलग हो
हाँ तो
सकता है।
वो पोस्टपोन तो नहीं होगी। अब ये पता करना है कि मैथ्स की है कि नहीं 31 को।
भाई
हाँ
ईवीएस का बताओ कल है।
और मैथ का क्लास भी नहीं है 31 से पहले।
भाई मैम
हाँ
इन्फॉर्म किया तो चांसेस तो कम ही है भाई 31st को होने का।
हाँ वैसे तो बात तो सही है, लेकिन मैम भूल गई होगी तो।
शुरू में पूछा था किसी ने कि मैम क्विज का क्या होगा, तो मैम कुछ रिप्लाई ही नहीं की।
वही तो।
हाँ मैम का फ्रीज हो गया उस टाइम ना।
जब मैम भूल ही गई तो हम लोग को क्या ही करना है, मैम भूल गई बोलेंगे क्विज हम लोग, मैम आपने बताया था।
आज मैम बोल देगी 31 को क्लास है ना, मैम बोल देगी कि क्विज है, तुम दो आज।
हाँ मैम तो मॉड्यूल भी खत्म लगा दे रही है ऐसे।
क्या ही कर लोगे?
क्या नहीं कर सकता है, जब
हाँ?
बोलेगी तो देना ही
टीम्स
पड़ेगा।
मैसेज कर दो मैम को।
1 बजे तक।
हाँ हो सकता है टीम्स में मैसेज करते हैं, ये भी पॉसिबिलिटी है।
हाँ मैसेज पूछ लो बस क्विज कब है।
हाँ
कोई इसी टीम से पूछ लो।
स्पैम कर दो सब लोग।
नहीं एक जन बोले यार।
एक जन बोलना है।
चलो उसका जो ये ज्वाइन कर लो यार, इसका ईवीएस का, वरना फिर नहीं ज्वाइन करना होगा।
नहीं बिल्कुल घुसने
अरे
देगा।
वो अंदर घुसने भी नहीं देता टाइम से पहले।
अरे सियाना
टाइम से
बंदा।
पहले घुसने, टाइम के
पहले
बाद भी नहीं
घुस
घुसने
जाना,
देता
देखो
है।
ना घुस गया तो उसका बंद करना तो है ही है।
चलो
चलो बाय।
बाय बाय।
बाय बाय।
कभी ईवीएस ज्वाइन नहीं करना है क्या?
रुक जा भाई, किसी से बात कर रहा हूँ।
अच्छा अच्छा।
तू तो करता नहीं साले किसी से। चोमू।
सामूहिक रूप में बात, ये सब बातें नहीं की जाती। चलो हम लीव कर।
ठीक, हम भी चल रहे।
मैथ कुछ नहीं आता यार, बचा लेना।